Unit 8, Part 9. Let's go through example I from page 163.4, another one that Klenk also works through. Should go without saying that you should try doing these yourself before you read my explanation. I also recommend, if you read through Klenk's explanation, write down the problem and see if you can then reproduce her steps to do it yourself, practicing seeing through what she's told you to see through. But here's me thinking it through. Okay, so here you have two premises and a conclusion. All right, so I'm looking at my conclusion. It's not A. Where does this formula, plus or minus a negation, appear amongst the premises? Only in one, so somehow it's going to have to be derived from premise one. Okay, so what is, here A appears, right? I need not A. So this formula plus or minus a negation appears as part of the antecedent of a conditional, right? The overall form of the thing in which it appears is a conditional, right? And that's where your attention has to go, right, towards the major operator of this formula that it appears in. Okay, it's a conditional. Okay, and what I want to get, in order to get this, is the antecedent of that conditional so I'm thinking immediately, modus tollens. Modus tollens is the rule that allows me to derive the negation of the antecedent of the conditional. Let me just think ahead a little bit. If I get that, what do I have? The negation of the disjunction A or B. The negation of brackets A or B. Happy face, right? That is a formula to which De Morgan applies. The conclusion of that De Morgan is the conjunction, and one of the conjuncts is itself not A. Okay. What did that thinking through, or that thinking forward? What did it get me? It showed me that once I do get the negation of the antecedent of this conditional, I'm home free, right? It's sort of, if you don't see it right away, it's complicated, right? How am I going to get from the negation of this to not A? Oh, I just thought through that it is pretty easy to do that. If I have the negation, De Morgan's applies, I have a conjunction as a result, so I simplify, and that gives me exactly not A. Okay, so now, where am I? I know that all I need to do is apply modus tollens to this, all right? If you think that much through, you're on the verge of realizing what? You're on the verge now of realizing that a proof bit that we learned applies now, right? Because where are we? You're at the point of saying, okay, I need to do modus tollens on this. What is the condition of that rule, right? What other formula do I need in conjunction with this one? This is obviously going to be premise one of the rule. What formula do I need as premise two of the rule? The negation of the consequent, right? So what do I realize? I realize that I need not brackets C and D, right? Okay, how am I going to get that? Right? Question mark, how do I get that? That's what I need, right? As soon as I have that, I'm home free, okay? If I have that, then that's the second premise to go with the first premise to get the negation of the disjunction of A and B, right? Not brackets A or B, and as I saw, I'm home free from there. So all I need is this, and I'm done. Okay, how am I going to get the negation of the conjunction of C and D, right? The only other premise there is not D, okay? So there's nothing to distract you here. In a moment we're going to do K, and try that one before I do it, but you'll see there is something to distract you in that one. There's no other formulas, right? So you're sort of forced to at least realize that somehow you have to get not bracket C and the negation of the conjunction of C and D. Somehow you have to get the negation of the conjunction in C and D from the negation of D, right? You're almost forced to realize, hopefully you do realize, this is where proof bit 3 comes in, right? Actually, what is it? Proof bit 4, because it's the negation of the second conjunct. Proof bit 4 is basically the same. But you need to get to the negation of a conjunction, and you are given the negation of one of the conjuncts. Now, if you understood and grasped and remembered the proof bits in their full formality and generality, you'll know that there is a path from the negation of one of the conjuncts to the negation of a conjunction. Oh, right, is a proof bit. Like pretty much all the proof bits, not all of them, not 11 like we saw, but many of the proof bits require the use of an addition trick. You add something different in each time. Sometimes you add a not Q for many of those conditional ones, or a not P. So what do I add? To figure out what I add, let me think this backwards. It's easy to think De Morgan's backwards. That's equivalent to not bracket, sorry. It's equivalent to not C or not D, right? Not C or not D. I think that would, so that's, and that, since this is the form of a disjunction, that I can get to by addition. Notice this as well. Look again at the formal presentation of the rule for addition. You're allowed to add the formula to the right or to the left, right? So the two forms are from premise P, you can infer P or Q, or, what is it, from Q you can infer P or Q. That's how I do it, right? Yeah, from Q you affirm P or Q. We're actually going to use the second form of the rule here. See the second form from Q to P or Q, because right, not C or D. It has to be in this order, right? This is not the same as not D or not C. Although if you did that, you could then commute. But you can do this by addition. Not C or not D, right? I've added to the left. All the other uses of add that we've seen and done, we've added to the right, but you can do that. That was prem. Okay, that's not C or not D. To add. Now I'm home free, you know what to do from here. Not brackets C, not C and D, right? The justification for this is De Morgan's. All right, that's my modus tollens. 1 for modus tollens, the negation of A or B. Right, now I De Morgan's that. Not A and not B. Not A and not B. 5 De Morgan's. 7. 6 simp. Okay? Like so, and that's done. Okay, the next one we'll do is K. We'll do it, start it in a new part.